Here we are taking the elements of circular motion. There are some practical definitions and explanations of the various terms which will be performed during this course of motion. Say a particle is initially at this place. Let us draw it as a red circle. Here, say this particle is revolving in this circular path with velocity v. Say this is the center of the circle and this straight line connecting particle with the center, it is called radius of the circle. Say it is r. During passage of some time, this particle reaches, say, somewhere here. Now, if we draw the new line connecting center with the particle, then this will be the line. If this is circle, then obviously this is also radius. Now, we can analyze this motion first, say in terms of the angle. Say this angle is theta. Theta here gives angular displacement of particle from in reaching A to B. Here, this is the distance traveled by this particle. In mathematics, we call it the path length as arc of circle. This r is considered as radius and this theta is angular displacement. This is center C. So as the kinematics of the circular motion, we must know what is this angular displacement and what is the rate with which it is changing its angular position. We can say that it is angular velocity. If we talk about the varying angular velocity, then there may be an acceleration which is called angular acceleration. Say, take the details from this figure and write down what are the elements of the circular motion. So first of all, I am taking this term angle, or we may call it angular displacement. It is represented as symbol theta, and which is mathematically equal to the arc length divided by radius. This term theta is called angular displacement. If this distance traveled or arc length is s, say, then we can write this term as theta is equal to s. It is very important to know that this angular displacement theta is vector or scalar. So please remember to know this fact that it is the only quantity which shows vector nature as well as scalar nature under different ranges. What is the meaning of different ranges here? So remember, vector, this angular displacement is vector if it is small quantity. It is large quantity. So what is the meaning of small and large? Small means it is somewhere under 10 degree. Large if it is 20, 30, 40, 60, 90 degrees. So this angular displacement may be vector if small and will behave like a scalar if large. We can take a very interesting example to understand this fact. See, there is this arrow is presently in the plane of this board and is pointing vertically upward. If I take two angular displacements, one theta 1 90 degree in this direction, so this becomes now after this theta 1 another displacement theta 2 which is also 90 degree is given this displacement in this direction. So this pointing arrow now comes in this shape. So after performing theta 1 plus theta 2 we got this result. In the other case, what we will perform theta 2 which is 90 degree first. So we just give theta 2 displacement first time, due to which it bends in this direction, now faces in this direction. So after revolving it with angle theta 2 which is 90 degree in anti-clockwise sense about the vertical axis, this arrow now becomes this way. Now if we perform the first angle theta 1 which is also 90 degree but in this sense which is upside horizontal displacement, then this arrow just becomes flat and reaches here. The result comes, the orientation of this arrow now becomes parallel to the line which is passing here, while in the previous case the orientation of the result is in somewhere perpendicular to the whiteboard towards me direction. So you can see, if angular displacement is of the order of 90 degree or 60 degree or 45 degree, means a large value, then the sum of two angular displacements is not commutative. Means here theta 1 plus theta 2 coming from this and theta 2 plus theta 1 coming from this are not equal. So we can say in this process, as theta 1 plus theta 2 is not equal to theta 2 plus theta 1, so it does not follow commutative law of vector addition, means it cannot be vector. So we will treat this angular displacement under these conditions to be scalar. If we take small angles, say 2, 4, 5 degrees, then the result comes almost same. You can perform this. So for small angles, this relation holds true, that theta 1 plus theta 2 is equal to theta 2 plus theta 1. So if angular displacement is small, then it can be treated as vector quantities. That's why I have called this quantity to be vector or scalar. This quantity has both type of properties for different value ranges.